Hello all, today in this video I'm going to make a demo for another kernel function with SVM. Already with the same SVM we have worked with two kernel functions, and in this video or demo we are going to work with an radial basis function kernel, and we are going to make a conclusion that among the three kernels which we have made at the implementation, which kernel is going to provide the better result. For that, we are using the heart disease data set which we downloaded from Kaggle. You can give it as a heart disease data set prediction, means you will just get that data set. So this data set is having nearly 14 entries. Among this, the first 13 entries we are using for the X variable, and the last thing which we are using for the Y variable. Then we are getting the info of the data set. Then we are getting checking whether we are having any missing values. Since our data is not having any missing values, we are not working with any pre-processing functions. But if it is having any missing values, means we have to work with the pre-processing function. Then we are getting the shape of the data set, and then we are just making a plot for the target variable, among which how zeros are target variable is having counts like 0 and 1. In that we are making a count that among which count is higher and what is the proportion of it, and we are plotting a graph recording it. Then by using the train test split function, and by use of the X variable and Y variable, as I said previously, we are using dropping the target variable to determining the X variable, and using only the target variable for the Y variable, and based on the usage of this and the test size as that is 20% for testing and remaining 80% for training, we are determining variables like X train, X test, Y train and Y test, and then we are working with linear kernel. For that, we are first importing the library which we are needed for support vector mission, and in this SVC we are specifying the kernel function with the kernel as linear, and then we are using the fit function. Within the fit function we are calling the train variables, and then within we are making the predict or the testing is done by use of the predict function. For the testing we are using the testing variables and make determining a testing variable. This variable we will be using for plotting the confusion matrix and also the classification report, and with this linear kernel we have got an accuracy of 81%. Then we worked with the sigmoid kernel. In sigmoid kernel it is same as SVC as linear only, but in the kernel of in the place of kernel in place of linear we will be giving a sigmoid, and we are determining its a prediction function, and by using this predicted function we are displaying the confusion matrix plot and also the classification report variables, and we have got an accuracy of 63%. In this code we are worked with the radial basis function SVM, and so for that in the place of the kernel we have given as RBF. All others are same only, but we have changed the name of the kernel, in this case SVMR, and we are predicting its testing variable and getting it within this variable. This variable we are using to display the confusion matrix with the X label as predicted values, Y label as actual labels, and title as confusion matrix. Here you can notice we have got only less percent of this, that is our data set is having nearly 1000 entries, but in your confusion matrix we are not getting 1000 entries because the confusion matrix is plotted by using the variables, testing variables only, and also the classification report is also plotted by use of the testing variables only, and here we have got an accuracy of 71%. We have also declared some other variables like precision, recall, F1 score, support, etc. Then we are making a comparison. For making the comparison, we are determining a variable called models. In that, we are determining the SVM3 SVM kernels like linear, sigmoid, and radial basis function. Then we are making a for loop. Within the for loop, we are training the model, testing the model. and determining some parameters like accuracy, mean square error, and mean R2 square. And then we are displaying the training accuracy and testing accuracy of every three kernels of SVM. And you can notice that all the three accuracy of every models, that is both training and testing, is displayed. From the here itself we can notice that the radial axis the linear SVM serves the first, next is the radial basis function, and last is the sigmoid SVM. Then we are making a table comparison. With that table comparison, we are making some highlighter points like the model with the highest accuracy will be shown with green color, and the model with the least accuracy will be shown with the red color. And the middle model, that is our model which we have implemented now, is in between this linear mod SVM and sigmoid SVM. In the next demo video, we will be working with some other kernel functions and make a comparison regarding it, and will make a conclusion that among the four kernel function which is going to provide better results. If you are interested in knowing some other demo video means, please let us know in the comment box. So if we are aware of it means, we will definitely make a video regarding it. Thank you.